Alright guys, in this video we're going to start off with an example problem, and then we'll talk about kind of the concept that goes with that example problem. So we're going to start off with this example. A college student going back to school from spring break travels an average of 60 miles per hour. If it takes a student 3.5 hours to get back to school, how far away from her school does she live? So the question is, how far away? That's a distance. This thing is 60 miles per hour, and we call that a rate. That's really how fast she's going. And then 3.5 hours is a time. And so we have these three variables introduced in this particular problem, and we've got to figure out how we can kind of write the relationship to answer the question of distance. So a quick, easy way to do this is to just make a little T-chart. So if I map out, I know that I'm going 60 miles for every 1 hour. That's the rate at which I'm traveling. And I travel for this amount of time. So let's look at the rate at which I travel. I'm going to use R to represent that. And I know that that's 60 miles per hour. And if I multiply it by however long I travel that far, I know if I multiply it by 1, I'm just going to get 60. But if I travel for 2 hours at that rate, I'm going to get a different distance. I'm going to travel a farther distance. So the relationship between these two is that I can figure out how far I travel by taking how fast I'm going and multiplying the amount of time that I travel that distance. So we've got this algebraic expression. We've got a couple numbers that we can plug in. There's 3 variables flying around, so we just want to try to keep everything straight. Remember, we want to know how far away. That's the question. And so in this particular case, we want to solve for D. We want to find the distance. All right. I've got my rate up here at 60 miles per hour, and I know that I'm traveling for 3.5 hours. So in order to solve for this distance, I simply just plug in for my variables. So I know 60 is equal to the rate. I'm going to multiply that by 3.5. And simplifying, I get that my distance traveled is going to be 210 miles. Okay, so we want to go through modeling these scenarios and modeling the relationships between different variables. This one hopefully was a relatively straightforward one. So what we want to do is kind of extend this concept or this idea. And again, just to reiterate what we're dealing with here, this is the distance traveled. Figure out how far we travel. If we take the rate at which we travel, or how fast, and we multiply it by the amount of time that we travel that fast. So the next thing to kind of look at is that last one was kind of nice and easy. I knew I wanted to solve for a distance, and I was given a rate and a time. So what if we're interested in finding some different information? If we have, we're given the distance and the time, but we want to solve for the rate. And so the way that we do that is we want to isolate that R. We want to isolate the rate by undoing everything that's being done to it. In other words, we want to solve this equation for the rate. Okay? So I can see up here in this equation, D equals RT, that I'm multiplying by T. And if I think about what I have to undo, or what I have to do to undo that multiplication, well, I know I've got to divide. So I want to get that T out of there. This is the thing that I want by itself. And so in order to do that, I have to divide by T. And whatever I do to one side, I have to do to the other side. And simplifying, I end up with something that looks like this. If I take the distance and divide it by the amount of time that I spend traveling, that'll actually give me the rate, or it'll tell me how fast I'm traveling. So in other words, distance, how far I travel, divided by how long it takes me to travel that far, tells me how fast I'm going. So the question is, like, when would I ever use this? Well, you use that when you're given different bits and pieces of information. Sometimes you don't necessarily know how fast you're going. You might know how far you have to go. and how much time you need to get there. So if I know, if I'm trying to drive 210 miles, like in our example on the last page, and I want to get there in 3 hours, I can figure out how fast I have to drive in order to make that happen. And that's exactly what we're going to do here. So we've solved this equation for the rate, and now we can use that in finding some different information. So we really just we've manipulated this original equation, D equals RT, into one that is more useful to answer this particular question, and then we just plug our stuff in. We plug in our information. So we know that the 3 hours, that's an amount of time. We know that the 210 is a distance. So if I want to figure out what my rate is, I've got 210 divided by 3 hours. That's equal to my rate. Plug that in, or simplify, I should say, and I end up with 70. And that is in, remember this was in miles, and this was in hours, so that's miles per hour. So if she wants to get back to school in 3 hours, and her trip is, she knows, is a distance of 210 miles, she needs to travel 70 miles per hour on average in order to make that happen. So another example of this type of problem, this is a very common type of problem, you'll see through algebra and also through, on an ACT or an SAT. So salesman earns $5 commission for every person he gets to sign on with his company. If the salesman makes $180 in commission in one particular day, how many people did he get to sign on with his company in that day? Well, let's start off with what we started with. A salesman earns $5 for every person. And we want to write algebraically what that means, okay? So algebraically, I know that for every one person I sign on, I'm going to get $5. So let's look at this. We'll use P to represent the number of people. And we'll use C to represent the total commission. So the total amount of money that he makes. Okay, so if I get one person, I know that's $5. If I get two people, I know that's $10. 3 people, that's $15, and so on. And so you can see what's happening here is all I'm doing is I'm adding $5 in for every particular person that I get. So if I want to write an expression that's going to represent this relationship between these two variables, well, my total commission, or the total amount of money that I'm going to make, is going to be dependent on how many people I sign up. And more specifically, I'm going to make $5 for every person. So my total commission is going to equal 5 times however many people I get to sign on. So this is the equation or the formula that we're kind of going to work with. This is an example of a direct variation formula because one variable, the commission, is directly affected by the number of people. So it's called direct variation. So just to finish this example real quick, we know that the total commission was $180, and so we can just use this. We want to know how many people they signed up. So what we want to do is we want to solve for the number of people that were signed up. And in order to solve for that variable that we've set up, P, I need to undo whatever's being done to it. So we know that this is being multiplied, so in order to undo multiplication, we need to divide by 5 and divide by 5. And we now have this new equation where my total commission divided by 5 is going to tell me how many people I signed on. And that's exactly what we're asking. How many people did he sign on with his company that day? So we plug in, we know that he made $180, so we plug in 180 into C. So we get 180 divided by 5, tells me how many people. Go through and simplify this, and that is 36 people that he signed on in order to make $180. So again, just another quick little example of how you can use one formula and manipulate one formula in order to get something that you're interested in. In this case, we wanted to know the number of people. One last quick example, more general example, just for this video. So very quickly, we've got this equation or this formula that gives us some kind of relationship between x, y, and k. And so what they want you to do is they want you to go through and they want you to solve for x. So there's my x. I need to undo everything that's being done to x. So in undoing this stuff, I've got to remember my rule. My rule is PEMDAS. Please excuse my dear Aunt Sally. This tells us the order in which we want to operate. But here we're undoing operations. So because we're solving for a particular variable, we're undoing operations. We actually work backwards through this thing. So the first thing I want to do is take care of addition and subtraction. So I want to undo this subtraction. I'm going to have x times y minus 5. And I know in order to undo negative 5, I got to add 5. So I add 5 to both sides. So x times y, these are going to cancel. I'm going to be left with k plus 5. Now remember what I'm solving for. I'm solving for the x. So I need to undo everything that's being done to the x. So the next thing that I work through, I've got addition and subtraction taken care of. Now I'm looking for multiplication and division. And when I'm looking for that, I see multiplication here. In order to undo my multiplication, I've got to divide by y. Whatever I do to one side, I do to the other. It doesn't matter if we're working with numbers or variables. All the same rules apply. And so what that ends up giving me is that x is equal to this expression, k plus 5 divided by y. And that's your answer. I've got x by itself. There's the expression that tells me what x is.